pituitary. We've got the upper regions of the pons there. It guarantees blood flow. Yeah. So we have coming up the vertebral arteries, making the basilar. The first branches, the most well, technically the most posterior branches here are the anterior, inferior cerebellar arteries. All right, coming off of the basilar. These are going to take blood flow to the cerebellum. Why don't I do? Let's draw this out as we go along. That might actually work. For everything here, with the exception of the basilar artery, they're bilateral. You have left ones and right ones. All right. Now, the vertebral arteries here have another cerebellar artery that come off before the basilar. The posterior inferior. The basilar artery then has a whole bunch of small arteries the pontine arteries. These supply blood flow to the pons. And finally, near the end, near the most anterior part of the basilar artery, we're going to have the superior cerebellar artery. All right. The basilar artery is then going to bifurcate into the posterior cerebral arteries. So I've just brought that down over here. Okay? Then staying in the circle of Willis, we have the posterior communicating arteries, left one and the right one. You can see them here. This little green artery, and this little green artery is going to tie in to a big jumble here that's going to tie into the interior carotid. Coming off right here, we're going to have the middle cerebral artery. Oh, God, this is getting ugly. Oh, it is. So pretty. And the carotid there. And then we have this, which is the anterior cerebral artery, the left and the right. And it's joined by the anterior communicating artery. what you should be able to do by next class is draw this out. Okay? It is much to your advantage to be able to do that. So, we can see here the anterior cerebral arteries. Here's one, here's the other one. Here's the anterior communicating artery. Here's the carotid. Here coming off is the middle cerebral artery. Here's the other posterior communicating artery, etc. Okay? This is a very nice figure. I have a couple of other diagrams of this figure we use later on in the semester. Got some radiographs as well. This is the area of the brain that we are most likely to see aneurysms. What's an aneurysm?
Brain
Yeah.
bleed?
A what?
A bleeding?
You know, it doesn't have to bleed.
Like clot.
It does. No, there don't have. Usually there aren't clots. Whoa. Oh, you can end up with it having a stroke. An aneurysm is going to be a swelling of an artery. You can have them anywhere you have, major arteries and pressure. But what you should remember about arteries is that arteries essentially have 3 layers of tissue. They're the 3, quote, lamina, 3 layers. And 2 of those layers are separated by elastic tissue. The elastic tissue in those arteries is incredibly important. Do arteries have to function under high blood pressure? High pressures? And the answer to that is yes, they do. However, those highest pressures come intermittently. So you have, your heart rate is, 70. Let's go for 60. 60, your 60, not pressures, 60 beats a minute. I'm doing 60 beats a minute because I'm lazy. 60 beats a minute means your heart is beating every what? Every second. Every second, an artery is under maximum pressure. And when it's under maximum pressure, there's a push on the artery and a slight expansion. Arteries are elastic. It expands. Between heartbeats, it contracts. It expands. It contracts. And what happens with an aneurysm is the tissue between those layers, specifically the elastic tissue, which allows for the recoil. Elastic tissue functions kind of like an inner tube in a bike or a rubber band, a balloon. You blow it up, it's under high pressure, it expands. You let go of the air, it contracts. Same thing with the blood vessel. The elastic layer allows expansion and contraction. Something damages that. It's overstretched, it tears, whatever. And what happens typically is that you might get a bulge in an artery. You might get a bulge off to one side. You might get a kind of a big loopy bulge. This is due to that weakening in the wall because of the elastic layer losing its elasticity. If it's losing its elasticity, that means it doesn't, it bulges out and it doesn't go back, but then the next heartbeat, you're putting high pressure blood in there. I've had maybe somewhere between 600 and 800 students in neuroanatomy. And you'd think of this statistic as mind-boggling. I've had 3 students of those 600 students that had aneurysms in their brain. They go, oh my God. And they were walking, talking, being students just like you. Because having the aneurysm means you have a bulge. It's only when the aneurysm dissects that you have, well, that maybe you die. But other than that, you know, your bad stuff happens. Okay? Because this is under some of the highest pressure in your brain, this region. That's good news. That guarantees blood flow. It also means you're under a very high probability of having an aneurysm between here and there. So, you know, what makes you strong kills you, so to speak. We're going to be going over that later on in the semester. But since we're going to be talking about headaches in a little while, you need to understand aneurysms. Okay? Are we cool with this? Yes?
How do you treat one? Or can
Very, very gently. Yes, you can. Actually, typically what they'll do, if it's a bulge like this, or if it's something like that, they'll actually come in and put in a stent. You go, they're gonna put a stent up there? Yeah, they can weasel along, they go in your carotid, come up, get a stent to where it belongs up there. A stent, when they first developed stents, they were mind-boggling because they were initially called smart metal. And you go, okay, come on, I know what's smart, and I know what's metal, and the whole thing about these is you put them in cold. When metal is cold, what does it do? It shrinks. When metal warms up, what does it do? It expands. You put it in cold, your body temperature causes it to expand. And we have a metal framework and structure in there that you can then build up connective tissue again. You can do all sorts of things. But it strengthens the weak spot. None of these people had stents put in. They were still, you know, basically every month or every 2 months they went in and had tests done. So yeah, and you know, people are out there doing that. Basilar aneurysms are, if typically here or here, you can get the full bulge in here as well. But a basilar aneurysm is kind of like, you know how you hear about people that are walking along and they drop over dead? It's probably a basilar aneurysm. Okay? Because what you have to remember, postcards. I like postcards. Okay, I find postcards interesting. Postcards have been around kind of since the beginning of photography. And as a result, some of the first things we saw in postcards were pornography, and it's incredible. You know, somebody invents a camera, first thing they're doing is taking pictures of naked women. The next thing they're taking pictures of are executions. So, just like today, sex and violence in the 1850s. Well, I have a copy of a postcard at home that is mine. It blows me away. It takes place during the Chinese Revolution of like 1912, 1913. Very nasty time in China. And it's the execution of somebody, okay? By having his head cut off. Very long, sharp sword, head comes off, and there is this 12-foot arc. That 12-foot arc is the blood from the carotid arteries. Shoots out, you know, it's amazing. It just, boom. Yeah. The photographer in me says, wow, that guy, either he, you know, those cameras weren't fast back then. He got lucky. Not the guy that lost his head, but the photographer. I guess the guy who lost his head has been immortalized, so to speak. But it's incredibly high